Okay, hopefully it works this time. Everything was deleted, so I get to go through this again. I'm going to try to go through it relatively quickly, otherwise I'm not going to have time to get through it. So, Chapter 3 review, Part 1, because I will get interrupted in about 9 minutes. First off, Chapter 3 exam prep. I'm going to be giving you a note card. Write whatever you want on that note card, and you can have it with you on the test. I recommend equations, reminders about units. Really, if you have those two things, you should be fine as long as you've been actually paying attention and doing your work in class. So there's that. We're going to run through these questions. Which of the following sentences best matches this equation's meaning? For that, we're just going to write out in words what this means. So that D is in reference to two positions, so that's got to be a displacement. That's the wrong marker size. Literally everything that can go wrong will go wrong. D is displacement equals final position minus initial position. If you find yourself not remembering what certain symbols and variables mean, that might be something worth including on your note card as well. X, F means final position, X, I means initial position, and so on. 18, describe a situation in which someone moves a distance of 100 meters, yet has a displacement of 0. To have a displacement of 0, you just got to start and end at the same spot. So if I walk forward 50 meters, and then I walk back 50 meters, there we go, I've done it. So 50 meters forward, then 50 meters back. You could also run a track that's 100 meters around, if one of those existed. All right, 61. What is the total distance traveled? They've given us what he did. He drove 70 kilometers west, which we generally say is the negative direction. So I'm going to put that as a negative 70 and add that to 100 kilometers east. But hold up, almost made a mistake. This is just looking for distance. I don't need to worry about direction, so I certainly should not have any negatives. He simply drove 70 kilometers, then he drove 100 kilometers. Add those together, we got 170. It's only when we get to displacement where I would need to worry about that change in direction. So then I would put a negative 70 plus 100 east, which is generally positive. So I'll leave that as a positive. Add those together, and we get 30 kilometers. If I wanted to, I could say east, but really the fact that it's positive in this context assumes that it's east. East is generally positive, so if you leave it as positive, I'm going to assume you meant east. Number C, or letter C. If Mike took 3 hours to complete the trip, what was his average speed? Speed is just distance divided by time. Distance we got up here. Divide by 3. I don't want to do that the long way, so I'm going to toss that into my calculator and get 56.67 meters per second. Then, what's his average velocity? Basically the same thing, but we're looking for the displacement divided by time, so I need to grab my displacement. 30 divided by 3, that I can do without a calculator. We get 10 meters per second. Again, the positive assumes east, so I'll just leave it like that. 64. An object that starts at a position of 5 meters, travels for 3 seconds at a velocity of -9, ends up at what position? So here, I'm going to list my givens, because I got a lot. So it starts at 5. So my initial position is 5. I don't know why I wrote 50. That's just a 5. I was trying to put an M for meters. It travels for 3 seconds. We got a time. It's got a velocity of -9. That negative's important. And we're looking for its final position. So now, we kind of have to use two of our equations. We've got displacement. That's xf minus xi. But we also have velocity, which is displacement divided by time. I'm going to kind of combine these together. Instead of having a d here, I'm going to write what d is actually equal to and put velocity is my final position minus initial position all over t. By fusing those two together, now I have an equation that I can actually use over here. I'll go ahead and plug in my numbers. People tend to prefer that. So velocity is -9. xf, I don't know, so I'll leave that as a variable. -5 all over 3. Now I just got to get xf by itself. First, multiply 3 up. 9 times 3 is 27. So -27 is equal to xf minus 5. We'll add 5 to both sides. But since that's a negative, the number's actually going to go down a little bit. And we get -22 meters. That's where our final position is. I believe all that checks out. I'm going to check the time because I may need to stop here. All right, Chapter 3, Review, Part 2. How long does it take to ride 5 miles on a bicycle going 20 miles per hour? We can start with our speed equation, distance over time. If I'm looking for time, I just need to get t by itself. So this sort of setup happens a lot, and I see people mess it up all of the time. So when you're solving for this bottom variable, the only thing you can do is get it up to the left first. That's your first step. Don't do anything else. So multiply both sides by t. That moves that up here. So we get t times s is equal to d. Then we're still trying to get t by itself, so we divide everything by s. Or the shortcut, if you can just remember, when you're solving for the bottom, it's just going to swap places with what's up there on the left. We get down here. Then from there, our distance, we're going 5 miles. We're going 20 miles per hour. Divide those, we get 0.25 hours. It's in hours because that's the unit that we were given. I could then convert that to minutes, and I could convert that to seconds, but I'm okay with hours. I'll box in my answer to make it easy for the person grading my paper, which on the test will be me. Number 75. Which equation is the best to match the following sentence? I took off the options because we don't need the options. We can just do it. The initial position is the final position minus the product of the velocity multiplied by the time. All of that we can shorten down into variables. The initial position. There is. That's another way to say equal. Final position. Minus. Then the product of the velocity multiplied by the time. That just means we take velocity and put it right next to time. There we go. Which that is a true equation that we could use if we were ever needing to find the initial position of something given the other info. 77. What is the average velocity of a man who runs forward at 8 meters per second for 9 seconds? I'll pause there, because based on that, I can figure out during the first bit of his journey, he went, what would that be, 72 meters? And back again at 5 meters per second for 3 seconds. Do you need to keep up with that back again part? That really just makes that a -5. 5 times 3, that's going to be -15 meters. And he did take an 8-second break. During that break, he didn't go anywhere. Just taking a break. So there's our three displacements. Since we're looking for average velocity, we just need our total displacement divided by our total time. So I'll do 72 plus 0 minus 15. Gonna double check that in my calculator just so I don't make a simple arithmetic mistake. 57. For the total time, we got 9 seconds plus 3 seconds plus 8 seconds for a total of 20. Simplify that down into a decimal, giving us 2.85 meters per second. Overall, accounting for the fact that he changed directions, went back the way he came, it's as if he just ran for 20 seconds going this speed. That would have got him to the same spot. Number 80. A runner passes the 2,000 meter mark of a race 380 seconds after starting. Right off the bat, I'm going to pause because this person's running. They just gave me the information I needed to figure out how fast this runner is. Well, I might as well figure that out first. Speed, it's distance over time. Does it say he or she? Yes, it does. So she, 2,000 meters divided by 380 seconds. How fast is she? 5.26 meters per second. Now, that's not my final answer. It was just a piece of the puzzle that I was able to put together based on the other pieces that I was given, which is kind of a good habit to get into when you're solving physics problems. If you see that there's something you can solve for, it certainly won't hurt to solve for it, and it might be helpful later down the road, as in right now. At what time after starting will the runner reach 5,000 meters? So now it's kind of like a secondary part of the question. We're still using the same equation. We know the speed, we found that. We know the displacement, or this distance, we were given that, and we're just solving for time. So I'm going to go ahead and solve for t, which once again is just going to make it swap places with what's up on the left, because the t would multiply up and the s would divide down. So all in all, I'll do 5,000 divided by the speed, 5.26, giving us about 950.57 seconds. That's how long it'll take her to travel 5,000 meters. Getting close to the end, a person 200 meters from a store walks directly away from the store at a constant velocity of 2.5 meters per second for 65 seconds. How far is the person from the store? Here again, we're kind of using our two simpler equations. Displacement is xf minus xi, and velocity is displacement over time. I'm going to fuse these two again and just have velocity is xf minus xi over t, because it's wanting me to figure out how far they end up at the end. So they're wanting me to find xf. So this time, instead of plugging the numbers in right away, I'm just going to get xf by itself, because that's a form of this equation we will end up using a lot. So first, multiply the t up, drop your marker, pick up your marker. Now multiply the t up. I like that. B times t is equal to xf minus xi. Add our initial position. So vt plus xi is equal to xf. There we go. I'm going to rewrite this slightly. Basically, I'm just going to flip everything around and put xf is equal to my initial position, that's where I started from, plus how fast I'm going, times the time. The reason I rewrote it that way is because it'll be more convenient down the road. But for now, I can use this to solve our question. We started out 200 meters. would go in 2.5 meters per second multiplied by 65 seconds. And as long as I'm careful, I'm just going to plug that whole thing into my calculator and get an answer. 362.5 meters. So here's another equation that I might just include on my note card. In fact, I have a note card and that's on there. And that's it. All right. If you have any questions about any of those, feel free to type in a private comment that sends an email to me that you have a question, and I'm usually pretty good about responding to emails pretty quickly because they come straight to my phone and I always have my phone on me. Do your best. Test very soon.